Hello everyone. Today we're gonna present our final project, network security. I'm Skudarov Maxim, and here is my teammate Aujan Nursultan. And our network topology and connectivity tests. Firstly, we have admin. It's inside zone with server with 3 admins PCs and 1 switch. Also, we have DMZ zone with web server, DMZ switch, and H main router. Also, we have internet. It's like outside zone with 1 router, internet switch, and attacker PC. We have also wide area network. It's provide connect to the internet. And here we have admin PC commands. First ping verifies inside default gateway reachability and local switching. Second ping verifies reachability to the DMZ gateway on the H router and confirms internet interzone routing. Third ping verifies the DMZ server is reachable from inside and allowed by policies. And the last ping verifies the wide area network interface of the H router is reachable and inside to outside paths exist. And attacker PC commands, ping 1 verifies connectivity from outside to the H wide area interface. Second ping verifies outside to DMZ reachability when expectedly permitted public service exposure. And the last one, ping, is expected to fail because he proves outside to inside is blocked by ACL and ZBF. It's like attacker, and we blocked this. It's segmentation enforced.
This slide shows how traffic between inside DMZ and outside is controlled using ICL, ZBF, and IPS, and how each rule is verified with router commands during the defense. This table defines the segmentation inside, DMZ outside, and the default gateways used by ICL, ZBF, IPS policies. This table is the step-by-step checklist used during oral defense to prove each requirement. Then AAA plus SSH admin roles. AAA enforces role-based access, successful SSH login. AAA is working properly. SSH access from admin K1 using admin 1 and network users was successful, and different privilege levels were applied according to AAA policies.
And zone-based firewall policy, ZBF, and also ACL enforcement, it's traffic control. ZBF enforces stateful policies between zones, 3 zones, inside, DMZ, and outside. Here we can see in screenshot first show zone security, first zone inside with some interfaces, gigabit Ethernet 000, zone DMZ with gigabit Ethernet 001, and zone outside with 0 to 0. And show zone pair security with service policy and destination zones outside DMZ and also DMZ. And the second ACL enforcement, we have ACL group, ACL 100. It's inside outbound rules, and outside in, it's outside DMZ allow plus outside inside deny. So in the second screenshot we can see show access lists with extended IP access list outside in and extended IP access list 100. Outside in we have 6 rules with 10, 20, 30, 40, 50, and 60. We have some permissions with TCP, ICMP, deny IP, some IP from attacker, and permit any other IP. In extended IP access list 100, we give permissions to ICMP and ICP, also some others IP. And IPS monitoring, Syslog plus routing proof. In first screenshot, IPS configuration is also enabled. We can see that IPS, if we will use attacker PC, IPS will block some rules. With some rules, IPS will block this, and attacker cannot connect to some other routers or PCs. And we can see some messages from IPS that attacker can attacker in previous actions he did some attempts to the connect and IPS is blocked. This output proves that iOS IPS is enabled and actively attached to the wide area network facing interface serial 0 to 0 inbound, meaning inbound outside traffic is inspected. And second screenshot, Syslog and monitoring, it's also configured. We can see that show IP route shows some messages with IPs, is connected, is directly connected, and so on. With also some interfaces, gigabit Ethernet and 0 to 0. And AAA server with services Syslog is also enabled with some messages. And routing table and Syslog proves directly connected zones plus default route to ICP. So interzone and internet forwarding are correct.
Then attack steps, attacker PK, ping 10.10.01, failed blocked, ping 10.10.0, 130, success, DMZ allowed. In this part, I demonstrate the attack simulation from the external attacker PK. We simulate an outside attacker trying to access different network zones. First, the attacker sends a ping to the internal LAN address 10.10.01. This request fails, which shows that direct access from outside to inside is blocked. Then the attacker sends a ping to the DMZ server at 10.10.0.130. This request is successful because the DMZ is intended to be reachable from outside. This proves that the network segmentation works correctly. The internal network is protected and only allowed traffic to the DMZ is permitted.
Yeah, and it was like attack simulation, security enforcement, and threat test. It's outside attacker versus protected white one, and attack proofs. Blocked internal access and allowed DMZ service. And now I will explain how this protection is implemented on the edge router. On the edge router, we verify the security enforcement. Using show zone pair security, we confirm that ZBF policies control traffic between inside, outside, and DMZ. With show access list, we can see ACL matches, which confirms that allowed traffic is permitted and blocked traffic is denied. In addition, IPS is enabled on the outside interface, providing protection against scans and flooding attacks. Together, ACL, ZBF, and APS create a layered security model.
In conclusions, key results. First, network segmented to inside DMZ outside with controlled inter-zone access. Then AAA plus SSH enforced role-based admin access, privilege separation. ISIL plus ZBF enforced traffic control, outside to inside blocked, DMZ only as required. IPS plus monitoring provide detection capability and audit trail, Syslog, SNMP, conflict evidence. Roles Skudarnov Maxim, perimeter and traffic security, ICL, ZBF, IPS, attack tests, routing proof. Then Aujan Sultan, AAA and monitoring, AAA server, SSH access, privilege levels, Syslog, SNMP, evidence.
So that's all. Thanks everyone for attention. Goodbye.
Goodbye.